Okay, let me ask you something. Have you ever wondered if you could have a conversation with an AI that literally no one else could understand? Like a secret language just between you and a machine. Sounds like something straight out of a spy movie, right? Well, as we're about to see, it's becoming a very real and a very important idea. So let's get into it.
So this is the big question we're tackling today. Is it actually possible for you and an AI to create a secret language? One that's so clever it stays hidden even if someone is reading every single word you send back and forth.
To figure this all out, we're not heading to some high-tech lab or a university computer science department. Nope. Instead, we're taking a trip to a more whimsical place. We are off to the 100-acre wood, because a certain bear has a very, very important secret he needs to protect.
So, our hero, Winnie the Pooh, has a problem. A big one. He has top-secret plans for his honey stashes, but these pesky heffalumps are always eavesdropping, trying to figure out where he hides the goods. So that's the challenge. How can Pooh talk about his plans without the heffalumps catching on?
You know, in the world of security, there's a term for this. It's called a threat model. It's really just a fancy way of asking who's listening and what can they actually do. In our story, the heffalumps can read all of Pooh's messages. They can see everything he says, but they can't get inside his house or read his mind, so they can't access his local files or his private thoughts.
So Pooh does what any of us would do. He asks his friends for help, and they come up with two totally different solutions. And this gives us a fantastic way to understand the two main approaches to keeping a secret. You can either build a better lock, or you can come up with a cleverer trick.
First up is Rabbit. Now, Rabbit is a very practical guy, right? His idea is simple. Build a big, strong lock. This is basically cryptography. You take your message, you scramble it all up into a bunch of nonsense, and you send it. It's super secure, no doubt. But there's a catch. Any heffalump who sees that jumbled message knows immediately that a secret is being sent. It's like a big, flashing sign that says secret message here.
But then we have Owl, and Owl, being the wise one, has a completely different take. He says, forget hiding the conversation. Don't make it obvious you're sending a secret at all. Instead, let's just hide the meaning inside a perfectly normal-sounding chat. This clever little trick is called obfuscation. The heffalumps can listen all day long, but they'll never even suspect a thing.
So let's put these two methods side by side. On the one hand, you've got Rabbit's cryptography. It is incredibly secure, but it creates what's called ciphertext, that obvious jumble of nonsense. On the other hand, Owl's obfuscation gives you plausible deniability. The whole conversation just looks completely normal. The real difference is what makes it secret. Cryptography uses a secret key, while obfuscation uses secret rules that only you and the AI know.
So Owl's idea sounds pretty brilliant, right? But how does it actually work? I mean, how can a bear of very little brain, or a regular person like you or me, actually learn to use this kind of secret language with an AI? Well, it turns out it's surprisingly straightforward.
It's really just a four-step process. First, you and the AI agree on a secret word for the day, a session seed, that you never actually type into the chat. That word generates a unique codebook just for that day. Then, the AI becomes your personal tutor to help you practice. And finally, you're ready to chat in secret.
Let's break that down. Say today's secret word is honey. Just by knowing that word, a temporary codebook gets created. So maybe today, the secret phrase, meet at 5 p.m., is hidden by saying, time for a nap. And urgent becomes a rumbly in my tumbly. Now, the really clever part is that tomorrow, with a new secret word, time for a nap might just mean time for a nap. This constant change makes it almost impossible for those heffalumps to ever spot a pattern.
And this is where the AI really shines. It's not just a chat partner, it's literally your personal language tutor. It can create drills for you, suggest different ways to phrase things so you don't sound repetitive, even come up with little memory aids to help you remember the daily codes. It can even role-play entire conversations so you can get fluent.
All right, theory is great, but let's see this thing in action. Let's imagine Pooh needs to send an urgent message to Piglet. He needs him to meet at 5 p.m. How does he do it?
Well, using their secret codebook, Pooh just says, I'm feeling a rumbly in my tumbly, which for today means urgent. Piglet gets it and replies, oh dear, is it time for a nap? Which confirms the 5 p.m. meeting. A heffalump listening in? All they hear is a typical chat between Pooh and Piglet about being hungry and tired. They get bored and just wander off. The secret is perfectly hidden, right there in plain sight.
So this whole Winnie the Pooh adventure has been fun, but now let's talk about why this really matters in the real world. Because we're talking about moving from protecting honeypots to protecting actual people in digital hotspots all over the globe.
Think about this number for a second. Over 1.4 billion people. That's how many people are living in countries with heavy internet censorship and surveillance. For them, a private conversation isn't about protecting honey. It can be about protecting their freedom, or maybe even their lives.
And this isn't just a theory. As one of the developers behind this very idea pointed out, this kind of technique could be used to jailbreak an AI in a country with strict information controls. That would allow people to get access to unfiltered information and to communicate freely.
I mean, the potential uses here are just vast. This could help activists organize safely under surveillance. It could protect our own personal data from being scraped and collected. It could be used to bypass frustrating AI censorship filters and provide a lifeline for communication in places where using standard encryption would immediately put you on a watch list. And that brings us to a final, really fascinating question. Traditional secrecy, rabbit's lock, is all about looking like a secret. It's obvious. But with Al's trick, a secret is perfectly hidden inside the most mundane, normal conversation. So you have to wonder, does secrecy even look like secrecy anymore? And what does that mean for the future of our privacy?